Hey, all, it's Miss Johnson, back at it again with some integrals. This is the video from your homework from March 26th. I never posted the video. That's my bad. I never made the video. That's my even more bad. But here we are. There's 11 questions. The first 7 are definite integrals. The next 4 are indefinite integrals. And all of them are going to use our notes, right? I've got the notes pulled up here because I always have the notes pulled up when I'm doing math. I'm going to post these in the video notes. It's going to be called 210326 async. So if you want to look those up and have those notes next to you while you're doing this, feel free. You can use my version. You can use your own version. I prefer if you used your own version because I think it's useful to have them written down. But here we go. I kind of smushed these all into one, but fortunately when you're doing definite or indefinite integrals, whenever you have a lot of different types of integrals, no need to fear, you basically just do them one at a time and then add the answers, right? And if one of these were subtractions, you would just subtract the answers. Let's change one of these to minus just for fun. Boom. So in order to do this definite integral, we move this down a bit. We do it one at a time, right? So we're going to do the first term first, 6 times x to the 7th. This one we use the power rule from our notes. The power rule says we keep the coefficient, we add 1 to the exponent, and we divide by the new exponent. And then a special version of the power rule says that when we have just a number, when we're integrating 3, for instance, it becomes 3x. Love it. The next 2 are exponential rules. Exponential rule, boom, 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 boom. The exponential rule says when we have a number to the power of x, we rewrite it and then divide it by the natural log of the base. And a special version of the rules says that when we have e to the x or a constant times e to the x, the integral of that just is the same function. Best function, e to the x. And then for the log rules, we say when we have a number divided by x, it becomes that number times natural log. And then on the end, we always put a plus c for the definite integrals. Definite is plus c. That's a finished question. Boom. Right. I think one of the things to note, I was going to say out loud, yes, one of the things to note is when your power is a number, that's when you use the power rule. And when your power is an x, that's when you use the exponential rules. Those are the difference between those two. Alrighty, right. Now, never give myself enough room. Now for trig, brushes, purple. I'm simply reading off of the notes here, right? When I say what's the integral of cosine, when I say it's sine, you might think, wow, Miss Johnson, you had to think really fast about that. Psych, I've got these off to the side, and when it says sine, I get negative cosine, right? Or when it says cosine, I get positive sine. I read it off, it says cosine, integrates to sine, right? It says tangent, I scroll down here, tangent is the natural log of secant. The integral of tangent is the natural log of secant. So I simply write that down, put a plus. Now I look for cosecant. The integral of cosecant is the natural log of cosecant minus cotangent. So the natural log of cosecant minus cotangent. And then I add plus c because I have to. Again, there was no thinking when I did that problem. Right? This is simply memorization or looking at the notes, either way. All right, for the indefinite integrals, the first step is what we just did. The first step of taking indefinite integrals is always just doing the definite version. And I did mix those up. This one is definite. And this one is indefinite. That's so confusing for y'all. I'm so sorry. Indefinite means there's not a definite start and stop. And definite means there is a start and stop, right? This one starts at -2 and ends at 0. And there we go. The first step to definite integrals is taking the indefinite integral, right? The first step is finding that area function. So here we say, what is the integral of the natural log of 3 times 3 to the power of x? It happens to be 3 to the power of x. How'd you know that so fast, Ms. Johnson? Bada bing, it's right here. Right? It's part of my notes. You're not gonna hear me say the word notes maybe a million more times. And then instead of putting plus c, I'm just gonna rewrite my boundaries kind of in the back of the problem. And now I put two big parentheses with a minus sign in front of them. I'm going to plug in the top bound to the first thing. I'm going to plug in the bottom bound in the second. And then I'm going to put this in a calculator and get that this definite integral boils down to 8/9. Use a calculator, you can use your head. Either way. Right, at this point it's just simplifying. But again, this is finding the antiderivative. This is plugging in bounds. And this is simplifying. Let's do another. If we've got the cotangent of x, we scroll down, we say the integral of cotangent is the natural log of sine. Natural log of sine. We put our boundaries over here for fun. We plug in our top boundary first, and we subtract our bottom boundary next. We double check to make sure our calculator is in radian mode. Calculator in radian mode. Let me just plug this in, right? I'm going to plug in natural log of sine of pi over 2 minus natural log of sine of pi over 4. I'm going to have the correct number of parentheses. I'm going to put the mode into radians, press enter. I'm going to get 0.34657. Boom, 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 boom. It's not even a 5. Come on. Right. I'm going to box my answer and be done with it. Here's what's going on, right? We've got, again, 11 problems. You'll find the antiderivative for all of them. For some of them, you'll plug in bounds. If you need help, I've got office hours from 1 to 3 on not Wednesdays and from 9:30 to 2:30 with a break for lunch on Wednesdays. Message me on Teams if you need more help. Bye, guys.